Astronomers have discovered a new super-Earth, and it sounds quite intriguing. This planet, named TOI-715b, is about 1.5 times larger than Earth, which is why it is called a super-Earth. Moreover, it is relatively close to us from a cosmic point of view, only 137 light-years away. By comparison, most exoplanets are located hundreds of light-years away, while all the most interesting things, such as black holes and nebulae, are usually more than 1,000 light-years away from us. So, could it be habitable? The habitable zone is an estimate of where on a planet conditions might be suitable for the existence of liquid water. We call this a certain distance from the star, at which the temperature on the planet should be normal, and water should remain liquid on its surface. This is not a very precise estimate, as it depends on many factors such as the type of star, the degree of reflectivity of the planet, its size, and so on. In addition, for water to truly exist, it is not enough to simply be in this zone. The planet also requires a suitable atmosphere and some other factors. Therefore, in 2014, we came up with a more stringent definition, the conservative habitable zone. This is a more precise term that identifies the best candidates that have liquid water. Otherwise, we would have too many potentially habitable planets that are actually not suitable for life at all. The concept of the conservative habitable zone is based on how much energy a planet receives from its star compared to Earth. If a rocky planet receives between 40% and 85%, it is considered to be within the habitable zone, regardless of how far it is from its star. Such planets have a better chance of becoming suitable for life. And yes, TOI-715b is there. This super-Earth orbits an M-type star, which is also known as a red dwarf. It is much smaller and colder than our Sun, about a quarter of its size and mass. But if the planet is in the habitable zone, that is the best option for life. Red dwarfs live much longer than our Sun, a yellow dwarf. This also means they have more time to develop small life forms on their planets. And this red dwarf is indeed older than our star. The Sun is 4.6 billion years old, while this star is 6.6, plus or minus a few hundred million. It has little magnetic activity, so it is not dangerous and does not flare up like younger red dwarfs do. Such flares can be very strong and harm planets by stripping them of their atmospheres. Although some planets around it have thinner atmospheres, it seems this red dwarf has already exhausted its potential. Such red dwarfs are not the places we are currently searching for planets where life might exist. Our super-Earth is very close to its star, completing an orbit around it in just 19 days. Since the star is small and the planet is so close, the transit of the planet in front of the star happens very often and looks very clear, allowing telescopes like the James Webb to easily study its atmosphere without spending too much time. If we talk about the James Webb Space Telescope, it opens a new era in the study of distant planets beyond our solar system. Imagine being able to see what gases comprise the atmosphere of a planet located millions of light years away from us. James Webb will help us find worlds where life may exist. Right now, it is trying to determine if TOI-715b has an atmosphere. If it does, its atmosphere will be easier to detect than that of a drier and denser planet. And then we will be even more excited, as it will seem like a good place for life. Moreover, there may be another planet in this system, also located in the habitable zone. We are not sure if it actually exists. It is just a candidate with a crazy name. But if it turns out to be real, it will be about the size of Earth. Furthermore, it will be the smallest planet in the habitable zone ever discovered by the TESS telescope. Another interesting thing about TOI-715b is that it may not only contain water, but could be an entire water world. Ocean planet is a type of planet whose surface is covered by an ocean or has underground oceans. They may not have much land because water can cover everything. Sometimes the entire planet may be covered with other liquids, such as lava or ammonia. When it comes to planets beyond our solar system, we cannot directly see water on the surface with current technologies. Instead, scientists look for water vapor in the atmosphere as a hint that liquid water may be underneath. And of course, we wonder whether life could exist on these planets, hoping it's not in the form of monsters like leviathans. Our modeling suggests that ocean planets may be quite common in our galaxy. This means that there could be many ocean planets yet to be discovered in it. But the most exciting part about TOI-715b is that it lies in the so-called radius gap of planets. If you line up the planets in order, there will be some that are both larger and smaller than Earth. But there is an unexpected gap in the planets that are roughly 1.5 to 2 times larger than our own. Where are they? This gap is interesting to scientists because it tells us something about how planets form and change over time. It's not that planets do not form in this size range. In fact, they start out larger and then lose some of their mass, like a balloon that gradually deflates. This might happen due to how they rotate around their stars. Stars strip away some of their mass as they revolve around them, similar to how our sun strips gas from the tails of comets. This gap holds many mysteries, and planets like our new super-Earth are clues that may help us solve it. We are not sure if something similar exists around red dwarf stars. Perhaps it has to do with the density of these planets rather than their actual sizes. So studying the planet we have discovered is even more interesting. It will help us learn more about distant stars and their planets. So recently we mentioned TESS, NASA's satellite TESS. The Transiting Exoplanet Survey satellite has been operating in space for 6 years and has achieved incredible success. NASA launched TESS because by that time we had already discovered more than 5,000 planets orbiting other stars, mainly thanks to the Kepler telescope. However, Kepler primarily found large planets, which are not necessarily Earth-like. We decided to direct TESS to search for small, Earth-sized planets around nearby bright stars, making them easier to study with future telescopes. Here's how it works. The camera observes stars and looks for changes in their brightness. If the brightness suddenly drops for a while and then returns, it may mean that a planet is passing in front of the star. But stars can dim for other reasons as well, for instance, due to flares or dark spots on their surface. Therefore, we need to handle this data carefully. The TESS telescope will show us the size and orbit of these planets. Then ground-based telescopes will help determine their mass. With these 3 parameters, we can figure out what the planets are made of and what they are like. Rocky, like Earth, or gaseous, like Jupiter. One example of TESS's discoveries is the TOI-700 system. The first planet in history similar to Earth was discovered there, TOI-700d. This exoplanet also orbits a red dwarf and is located even closer to us, at a distance of about 100 light-years. Unfortunately, it is highly unlikely that life could exist there, because the temperatures are just insane. Another major discovery was made in the AU microscopy system. TESS discovered a planet about 4 times larger than Earth and another one nearly 3 times larger than Earth. This system has become a key area for studying how stars and planets form and evolve over time. TESS has also discovered many other exciting findings, including supernova hot worlds. And now, as the telescope has been operating for many years, we can expect new interesting discoveries. Thank you for watching.